So I believe we're going to be doing our first panel discussion. So I'd like to invite some of the members of OpenPOWER up here to join me. I'm Scott Schults. I am from Mellanox. I've been with OpenPOWER from the beginning. I wasn't in the closet with the rest of them, but I was at the first board meeting. So we have Rene Sakakibara-san from Hitachi, Rene from Atos, James from Inspur, Kang from Wistron, Adi, and hi, Rene.
Hi.
Hi, Kang. Let's see, I think I will sit over there. Okay. Thanks for joining us. We've been making a lot of progress here, I think, on the hardware side, and I really appreciate you guys joining us. So I want to thank both Rene and Sakakibara-san from Hitachi, James from Inspur, Adi and Kang. And because we all love hardware, we really only have about 20 minutes for this session. So I'd like to set the context of the discussion around 3 general points, right? Really, what is the value of OpenPOWER for you and your customers? How is your solution fitting into the ecosystem and vice versa? And then, what key features do your solutions bring to the table, okay? So I think we'll start with Atos. We'll ask, Atos is really a known global leader in systems integration. What role do you see for Linux on OpenPOWER solutions in the enterprise? And how do you facilitate the integration? Are we all mic'd up, or do you have, I'm sorry. Here's an extra one.
Thank you. Yeah, this is better, I think. So we see a growing interest also from our enterprise customers for Linux, OpenPOWER, open source. We help them to facilitate our customers in different ways. One thing which is the relatively easy one is the new projects. We do full implementations based on Linux and open source. The more complex are the migrations from legacy solutions into the open source world. There we have invested in a tool set which helps our customers to migrate, and maybe even more important, to do assessments to quickly see what the impact will be to do the migration of a legacy to an open source Linux environment, which can be implemented on our OpenPOWER solutions. And there is the bigger advantage for our customers in terms of a TCO gain. And lastly, we are working on leveraging the new capabilities we see today, like in GPU database processing, which becomes available with the current OpenPOWER solutions, and with the latest OpenPOWER server we have announced recently.
Okay, thanks. Sakakibara, Hitachi launched your supercomputer, the SR24000, right? Which is an achievement for OpenPOWER using Power 9. And of course, the Tesla V100 GPUs. So Hitachi is offering this to the Japanese market. Could you tell us Hitachi's view on the Japanese HPC market and Hitachi's strategy on how you're developing attractive products and solutions for the market?
Yeah, in Japan, as in the other regions, there are 2 major sectors, public and private. And Hitachi has been focusing on the public sector, especially on National Research Institute, because they require relatively large systems. And these customers tend to write their own programs by themselves, Fortran or C languages. And one difficulty they encountered is that they need to port their programs by themselves onto other platforms whenever they change the platform architecture. So Hitachi has been supporting these customers for a long time. And we have technical advantage in this area by our automatic parallelizing compiler. So now Hitachi developed a new version of Fortran compiler based on OpenPOWER technology. It detects automatically parallelism in the program. And with this new Fortran compiler, users can port their program very easily, and they can get better performance without rewriting their programs. So Hitachi is going to provide our solutions with this Fortran compiler. So we are going to provide the products, OpenPOWER products in Japan.
Is Hitachi offering your solutions only to the Japanese market, or is this for worldwide?
Yes, Hitachi is willing to offer in the other regions if there are the requirements as Japanese customers has. And about our Fortran compiler, we are going to support various kinds of directives, such as OpenSCC, OpenMP, and even other companies' directives, supercomputer directives, Fortran compiler directives, in addition to Hitachi compilers. So it makes users to port their program to OpenPOWER technology. So it will be very attractive solutions for every users, HPC users.
Okay, thank you, thank you. I think the next question here is for James. So what's the competitive advantage for Inspur?
Okay, come to the competitive advantage. I want to talk more about how we think about the competitive advantage of OpenPOWER system, and then to talk about a company's advantage. Yeah. In my opinion, I think first of all, the first advantage should be is the most advanced technology genius, because OpenPOWER inherited power system. But I believe most of us will believe power system have an overwhelming advantage in computing technology. For example, in terms of performance, in terms of reliability or serviceability, yeah, power systems have very advanced technology. So and because OpenPOWER is opening, nowadays we have a chance to look into the details, look into the technical details and design details. And we found them deeper we dig into power system, we found more advantage. Yeah, so the first advantage should be the leading technology. Yeah, the second, I think the obstacles to grow OpenPOWER ecosystem will be more easy to be overcome than any other new emerging computing system. For example, other small guys, because for OpenPOWER system we have too many features. We have too much performance, with a little bit power consumption, for example. But we are doing subtraction. Technically, I think the subtraction is easy. It will be more easier than to do addition. For other guys, they are doing to do, for example, performance increase and to do new feature to do what power has done. But I think it will be more easy for OpenPOWER ecosystem. So the advantage should be we have more prospective ecosystem for OpenPOWER. That is why Inspur, we create a joint venture with IBM to do OpenPOWER business. We do see a very good prospective, future prospective ecosystem. And but the second about the company's advantage, Inspur, actually, we have keeping the most market share in China for many years, and we have big customer base, and we do a lot of joint development with customer, especially with the internet large-scale data center customer. Yeah, we have a very good customer base, and also to develop OpenPOWER business, we can leverage Inspur's big volume and a lot of rich set of common building block from x86. Yeah, I believe this should be the advantage of company to develop OpenPOWER system. Yeah. So I'm quite more confident that we will win the OpenPOWER market just like we won the x86 in China. Mm-hmm. Thank you.
Very good. Thank you. Thank you very much. Hi, Adi.
Hello.
All right. So how about now? I know you have an OpenPOWER blog.
Yes.
I actually read it.
That's so cool.
Quite a bit. But
thank you.
So for those of you who don't know, you could introduce yourself just briefly and.
Yeah. Absolutely. Yeah, I'm Adi. I'm a senior systems design engineer at Rackspace, and I work on our Power 9 server, and in collaboration with Google, and we call that same server the Zeus motherboard and chassis wrapped around it. We call it Barrel I Generation 2, as a follow-up to the previous server that we generated yep, and I'm here on this panel, and overall, when we do hardware design, if you know the background of Rackspace, Rackspace offers IT services on top of hardware. It doesn't offer hardware itself directly. So bring a little bit of, like, say, solution and serviceability aspects to hardware design, and that's how I want to put it.
So what's really special about your server, about Barrel I?
Yeah, actually, there's too many cool things about the server, just to kind of wrap it up in a few minutes, but I do have a talk on that, deep dive into that later today. I'm going to touch the high points here. The Barrel I G2 server, which has a Zeus motherboard, essentially, it's in an open compute form factor. So it's built for large-scale, scale-out deployments, if you will. And then there's a lot of serviceability and focus when we built the system. So it's very easy to use for hyperscale data centers. There's some of the other more cooler things is basically it's a 48-volt server. It's a very disaggregated implementation of 48 volts. The CPUs and DIMMs, they use 48-volt point of load today, but GPUs and storage is going to get there. And when that happens, we're in very, very good position to support it. The server has that kind of a design. And for storage side, the server supports SAS, SATA, and NVMe in all the slots. So that's kind of very flexible architecture, essentially. It'll help Rackspace use it in different products without actually having a different SKU for each of the server. And the last thing I want to touch on is that the server supports, for a scale-out server, it supports both NVLink and OpenCAPI accelerators, which is very flexible. We've kind of made a lot of options available so that you can use the system the way you want to.
So maybe could you tell us how you're solving for emerging AI workloads using this server, and really how does this really benefit the users in the end game?
Yep. Yeah. We've talked about a lot of hardware features and cool things and things like that, but eventually you want to solve for real-world workloads, right? Some of the workloads that we are looking optimally on this server is essentially like deep learning workloads. Not just like, say, deep learning when it comes to GPU. It can be used for a lot of GPU analytics, high-speed data analytics, a lot of frameworks around that can be really good to be leveraged on this platform. We're also looking at like NoSQL databases and things like that. So that's the which workloads, right? But how, right? I'm going to point out a little bit about how this differentiates that for a specific workload. Deep learning today, I think, there's various talks and various venues people mention what deep learning, there's one hindrance for deep learning to scale, and that is, actually there's two hindrances for deep learning to scale. It's the slow CPU to GPU, connection. In the mainstream systems today, like Gen 3, PCIe Gen 3, right? And the other bottleneck is slow server-to-server networking. We're just looking at 100 gigs, essentially, of bandwidth between server to server. And that's, sometimes not enough, for deep learning workloads. In this system, we leverage the CPU to GPU NVLink for the first hindrance, to remove the first hindrance. And the second one, actually, I'm going to have a little bit cool demo later today, where we're demonstrated 1 terabits per second server-to-server bandwidth. That's pretty significant, essentially. Yeah. And not many systems can support that. Yeah.
Okay. I'll look forward to seeing that. Okay. So we have Wistron with us as well. And would like to know what are some of the benefits that Wistron brings as OpenPOWER products provide, your solutions and how you work as a business partner.
Yes, thank you, Scott. Good morning, everyone. My name is Kang Pao. It's my honor to represent Wistron in this OpenPOWER Summit. Wistron is a professional design manufacturing service company. We provide all kinds of products for Tier 1 brand name companies since the year 2000. Wistron Enterprise Business Group, we work with IBM on PowerPC product line more than 15 years. Our first project is based on Power 5 processor. And today, we are very happy to launch multiple Power 9 servers together. Wistron capability involves electrical design, firmware coding, thermal structural simulation, mechanical level 10 system integration, and regulatory, reliability, and compatibility testing. The key message is Wistron provides customization services and one-stop shopping solution to our customers. We hope today we can work with more partners here to provide more mature ecosystem and to help the OpenPOWER community together. Thank you.
So you also have a couple of new Power 9 platforms. Can you first tell us a little bit about that and really what is unique and different for these new platforms?
Sure. Yes, thanks, Scott. Yes, we understand there are 3 types of Power 9 processors, 3 types. And Wistron is demoing 2 Power 9 servers today in our booth. The first one is based on Lagrange processor. Our internal code name is Mihawk. Mihawk is a standard 19-inch 2U server. It comes with the open cabinet capability, PCI Gen 4 connection, and maximum 4 terabyte memory capacity. It's a very good for big data, AI engine, that kind of application. The second one is based on Sforza processor. Our internal code name is Sanji. Sanji is a 2OU 21-inch OCP form factor. And it also comes with the PCI Gen 4 connection, NVMe storage, and a 48-volt power busbar design, which means for hyperscale data center and cloud environment, they can utilize this 48-volt design to enhance and optimize the power efficiency. That's our special.
Okay, okay. So Rene, we touched just briefly on AI. We heard from Adi. What role does OpenPOWER play in your strategy around machine learning?
In general, power has a long history within our company. We celebrated last year our 25-year anniversary using power technology and developing together with IBM. And OpenPOWER has reinforced the strategy and gave much more options than we had before. In terms of machine learning, one of our key elements is the recently released server, which we call the L3 OP90, in which the OP stands for OpenPOWER as a recognition that it is a server developed out of the OpenPOWER initiative. And that is clearly something in our agenda to continue to work with. And we are currently working on initiatives to also have edge devices built based on cooperation within the OpenPOWER community.
Okay, thank you. Thank you. Maybe one more for James. Let's see, I think I had one more here for you. Actually, maybe the similar question. What is your key market targets moving forward?
Okay, we will develop a full state OpenPOWER product line to meet the needs of different industry. I think the major, we are talking as major three market. First of all, we are targeting large-scale data center customer to host their new emerging computing-intensive workloads to provide more options for large-scale data center customer to refresh their hardware platform. Especially, we use OpenPOWER based product. We have, for example, new platform with OpenKP PCIe 4.0 and a lot of new most advanced leading technology to provide to the cost service or big data customer. And the second is about artificial intelligence application. We found there are more and more artificial startups, companies, application. They are very focused on, for example, image or voice and recognition or augmented driving, and a lot of AI application innovation in the market. So we will provide a more integrated solution, combine the Inspur AI platform and IBM Advanced Power AI solution together to provide the AI end-to-end AI solution to these startup companies. We see that will be a very big potential. The last one, I think, is about industry internet. In China, the government is promoting the development of industry combining big data and IoT of modern manufacturing. So I think we will combine a database application and a power-based virtualization technology to help customers to build a more flexible, more secure private cross-service infrastructure for customers to boost the high-end digital transformation of enterprise, I think.
Okay, thank you, thank you. So any final thoughts you'd like to leave us with?
Yeah, I think Power 9, right? It's a breakthrough processor of our time. I think it's enabling a new class of workloads essentially. But to get there, there's still many new things that we have to kind of solve for. And the road to kind of do that, it's actually together. It's through collaboration, and that should be an industry-wide collaboration, so that every one of us can benefit here, right? Yep.
Okay. Well, I'd like to thank the panelists for being here. I really appreciate some of the insight and some of the insights to your hardware. And I totally agree, right? I mean, we've done so much so far through the work of open collaboration from all of our respective companies and from a membership perspective. And I look forward to not only a very successful 2018, I wish you all the best moving forward.